Hello guys, let's continue the solution of the worksheet which is talking about the concavity and the inflection point. Here in part 2 I solved exercise number 1 in page in which page? In page 4. Now I'd like to remind you what is the meaning of inflection point. The inflection point is a point at which the value of x at which the function has the has tangent line. Okay, the concavity changes of the function. The function changes its concavity. Okay, also the second derivative equals 0 or does not exist, but not at each value of x. If the second derivative equals 0 or does not exist, we have inflection point. Okay, here let's solve this one. Solve part number 2. Who will help me? The first step here, I have to find what? The first derivative as our steps. Okay, step number 1, find the derivative, which is what? 3x to power 2 minus, since we talk about the the inflection point, I have to find the second derivative. Okay, 12 what? Negative 12x plus 12. Okay, after this one, I have to find the second derivative because I can't find the second derivative without finding the first derivative. It will be 6x minus 12. Okay, then find the values of zeros, the values at which the second derivative equals 0 or does not exist. Since we have a polynomial function, I will find the zeros at the case in which the second derivative equals 0 only. Here set x minus 12 equal what? 0. Okay, set second derivative equal what? 0. Implies what? X equal 2. This at x equal 2, it is possible to be inflection point, but when it is an inflection, if that the function is what? Change its concavity. In this case, I have to use the second derivative. Okay, discuss the concavity, use the second derivative. Here, second derivative. Increasing and decreasing, I use the first derivative. Write the point at which it has 0. Negative infinity, here what? Infinity. Test value, as I did before in increasing or decreasing, I do with the second derivative. Here, I'll choose 1. And here I choose 3. Then replace in the what? In the second derivative. Replace in the second derivative, which is, when I replace by 1, 6 minus 12, it will be negative 6. Second derivative equal what? Negative 6. Less than 0, so the function concave downward. Okay, concave downward. As 3, it will be 18, it will be the second derivative, it will be 6 more than 0, so it will be concave what? Upward. And here, at this point, at x equal 2, such that the second derivative equals 0, the concavity changes from downward to upward. Downward to what? Upward. So it will be what? Inflection point. Okay, here what I have to write, I have to discuss the concavity as he asked me in the question and the inflection point. Here we write f is concave on which interval? Upward. Upward on which interval? 2 and infinity. 2 and infinity. F is concave downward on which interval? Negative infinity and 2. Downward on what? Negative infinity and 2. So, inflection point at what? At which point? 2. Then replace in the function to find its y coordinate. Its y what? Coordinate. Okay. Wait just 1 minute. Here at which point? I already found it, so wait a minute. Okay, here I'd like to write it in easy inflection point. Where is the inflection point? Okay, inflection point at which value? 2, and replace in the function, original function, it will be 8. It will be 8, 2 and 8. I hope you understand. Here, when I'm talking about the concavity, I have to use the second derivative. Second derivative test. Here, I use it, as you see, use the number line as I did before with the first derivative to find the interval on which the function is increasing or decrease. When we talk about the concavity, I'll do with the second derivative as I did with the first derivative to find the interval. Understand? Here, concave upward on this interval, concave downward on which interval? Downward, okay. On which, let's downward. Okay, downward on this interval. I hope you understand. All of the exercise by the same way. But I choose any polynomial, you can solve it by this way. It's so easy. So easy. Follow the same. This one, look here, I'm sorry. Look here, this problem is so easy. This one, I will use the product, what? Rule. We use the product, what? Rule. I think you can apply the last two examples. You can look here. I solve number 1, number 2, and 3, 4. It will be homework, and I'll write the model answer and post it on the LMS. Okay, and I'll post it on the LMS. Okay. Here, I'd like to talk about this one. Okay. Here, the second derivative test. Let f be a function such that the first derivative c equals 0. It means the critical number, and the second derivative of f exists on an open interval c. If the second derivative at this critical number greater than 0, it means the function when the second derivative greater than 0, it means it is concave what? Upward. It is what? Concave upward. In this case, we have relative minimum. If the second derivative less than 0, it means the function is concave what? Downward. And this case, the value of the function at this critical number, or the value at which its first derivative equals 0, is what? Relative what? Maximum. Okay? Here, relative what? Minimum. If second derivative at this value of x such that the first derivative equals 0, the test fails. The test fails. That is f may have a relative maximum, a relative minimum, or neither. In such cases, you can use the first derivative test. Yeah, if I use the second derivative test, which I use this test to identify what? Relative extrema. I can use first derivative test to identify the first derivative test, to identify the relative extrema, increasing and decreasing. The second derivative test, I use it to identify the relative extrema. the relative extreme. But if this test fail, I can use the first what derivative. As you see here, if we find the zeros of what? Wait a minute. The zeros of the second, please focus, the zeros of the first derivative, okay? And we replace in the second derivative the zeros, only the zeros, not does not exist, okay? Not does not exist. Okay, again, if we replace by the value of x, at which the first derivative equals 0 in the second derivative, okay, and we get value greater than 0, so the curve concave upward, and in this case we have minimum value, relative minimum value at this value of x. If we replace by the value at which the first derivative equals 0 in the second derivative, and the value will be negative less than 0, the second derivative less than 0, it means the curve of the function concave downward. In this case, at this value, FC is what? Relative what? Maximum. It's so clear from the graph. It is what? Relative maximum. Okay. Miss, now please, can you show me how to do or how to find the relative extrema using second derivative test? So easy. I'll show you. I'll solve the first one. Okay, then I'll post the solve of the others question. Here, as you see here, the first step, please focus. I have to find what? So trivial. Find the zeros of first derivative test. It will be general power rule 2x minus 5 all to power 1. Okay, submit it. Then find the 0. The first step. Second one, find what? Critical number. It will be 2 multiply x minus 5 equal what? 0 implies x equal what? 5. In the domain of the function, yes, it is in the domain of the function, since in the domain here, I forgot to tell you, all real number. Okay, that is what? Critical number. By using the critical number, replace in the second derivative. But if we find the second derivative test, the second derivative, third step, second derivative. Okay, it will be what here? Differentiate the first derivative. 2 multiply function, it will be 2 multiply the derivative of this function 2. What is the derivative of this function? Is 1. So the second derivative equal 2. It means greater than what? 0. For all, please focus, x in the domain. Clear? Please focus. So, f 5 is what? Second derivative at the critical number equal what also? 2. Greater than what? 0. Since it is greater than, okay, we have relative maximum or relative minimum. Positive, it means concave what? Upward. This what? Relative, we have a relative minimum because concave up, we have minimum. Concave down, we have max. Relative minimum at which point? 5, and replace in the given function to find its y coordinate, it will be what? 0. Relative minimum at 5 and 0. Again, the first step, find the domain. Okay, sorry, this one I have to do it before I begin to solve. Okay, before I begin the steps. First step, find the derivative, find the critical number. The critical number must be in the domain. Okay, then replace in the second derivative. But here, when I find the second derivative, it is a constant. It is positive for all of the values in the domain. So if the second derivative also at 5, it will be 2, greater than 0. Set the derivative, second derivative positive, it means it is concave what? Upward. In this case, we have a relative minimum. Add the values of x, this critical number, then replace in the original function to find its y domain. I hope you understand well.